Hey everyone, I'm Baffled by Reality. We had a fun time in the previous video taking a look at Simon Dan's $5,000 challenge, but it's time to get back to business as usual. Today we're going to be talking about some scam-like flat earth experiments that have been done or have been proposed. I'm going to be talking about the laser experiment and the force the line experiment. And if there's one thing I know about flat earthers, is that they're terrible at experiments. We've had flat earthers put cameras on gates, flat earthers raise and lower cameras over uneven surfaces, spinning wet balls around, shining lights at each other, etc., etc. Despite all of their trials and errors, they don't seem to be any closer to actually performing a decent experiment, let alone interpreting results in a way that aligns with reality. It's truly baffling. We have dozens of experiments we can do to observe Earth curvature, rotation, gravity, etc., and yet flat earthers avoid repeating these experiments or explaining why they would be incorrect, instead choosing to perform the silly types of experiments we mentioned earlier. And since we brought it up, let's take a look at these laser experiments. It essentially works by having one person stand really far away with a laser pointer, and then another person observing it. Flat earthers then rejoice because they believe it would be impossible to see this light at that distance on a globe Earth. Now, we shouldn't have to point this out, but this is generally a bad experiment. It's something that's done by both flat earthers and normal people, and it's been done hundreds of times. Most importantly, its results have shown both curvature and lack of curvature depending on how much effort you actually put into doing the experiment. Let's first dispel the illusion that a laser beam forms a perfectly straight line from A to B. Even the best of lasers diverge over distance. The diameter increases over distance, lighting a larger and larger region. Now, this by itself would not help the beam be seen over the curvature. And this is where refraction comes into play. Refraction is where light is observed to bend when moving between mediums where its speed is different. You can see this pretty easily when light hits water. This also happens in air over great distances. It's typically due to a difference in temperature. So as light passes through the different layers of air, it bends little by little. This is what allows for most pictures that flat earthers love. In all of these photos, you can clearly see some significant distortion, which is indicative of refraction. So when they try to view a laser over large bodies of water, they're almost always going to see it. Not because the Earth is flat, but because of divergence and refraction. Had they been just a little more scientific, they could have measured the light. By looking at the position and the diameter of the beam, they can start to take these variables into account. If you look at the beam at multiple points along its path, you get a clearer picture. Doing these steps typically proves curvature, so most flat earthers skip it. And because flat earthers get debunked on these laser experiments so often, they've cooked up a new grift from an old idea: force the line. This was proposed by a flat earther way back when, and I'll go ahead and let him explain it a little.
So, this is force the line. Here's my idea. What we do is, we need 2 miles of relatively flat land, or it's easier if we use flat land. I'm thinking Oklahoma, Nebraska. Florida would work, but there's a lot of crap in the way in Florida. There's so much foliage here that we would need maybe we could do this under power lines, but who really wants to work under power lines? So here's what we do. We set posts over a 2-mile stretch of land. What I've got here are my posts. Okay? 10 feet on center. Here's your first post, second post at 10 feet, third post at 20 feet, all the way down to 2 miles, 2 miles away. Here's your last post at 10,560 feet, or 2 miles, and your second to last post at 10,550 feet. Okay? Got my break line in here to show that the distance between these 2 posts is 10,530 feet. You see what I've drawn here, okay? Now the idea is everything is based off the first 2 posts. Okay? What we do, we set the posts in a straight line. Very, very easy to do. Contractors can definitely do this. And then between the very first 2 posts, we construct a beam between the 2 and level that beam. Okay? We level this beam, okay? Make it level. This is typically how beams are constructed. You always level them out, unless there's a roof slope or something. But for a floor beam or something, you would always level it. Anyway, so this point right here is this point on the Earth, if we live on a convex sphere, okay? Meaning that when this beam is leveled, there is an imaginary line perpendicular to the center of gravity of the Earth, extending to the center of the Earth. And then we do the same thing all the way to the end. We level each one of these beams all the way for 2 miles. Okay? So, every time you level one of these beams, it should be it should be perpendicular to a line extending to the center of gravity of the Earth. So over 2 miles, those beams will actually follow the curve. They have to. If a level works, the only way it can really work is on a sphere is if it works with the center of gravity. Okay? Then, what we do is we use a rectilineator type device below it to force the line. This very first beam we construct right here is perfectly parallel, or as close as we can get to perfectly parallel to this beam. It's leveled too. We level that beam, okay? But then for all of the rest of the beams on the forced line, as I'm calling it, we use a connection here. It forces this beam, it forces a right angle connection to the first beam, okay? So, say this is our first beam is leveled, okay? It's leveled out. The next beam that comes in, we use precision machine work, or like a CNC machine, or something similar, to create a connection that forces a right angle connection to that first beam. Okay? So now, this second beam is not actually level. You wouldn't be able to tell from the naked eye, and if you put a level on it, it would probably still show that it's level because our levels are not that accurate. But it will stay in line with this beam, and we do that all the way down to the end. Now, we can just use a rectilineator type device. We don't have to build these beams. We don't need 1,057 of these beams on the bottom because they're going to be expensive to make a right angle connection like this. You see I've got 90 degrees at all 4 corners. We can just leapfrog it and just mark the columns or the posts as we go until we get the line. Now if the Earth is a sphere with a circumference of 25,000 miles, then over 2 miles we should see from this point to this point a drop of roughly 32 inches. You can draw this in AutoCAD and prove it. This is what it has to be if the circumference of our world is 32 inches, or 25,000 miles.
Now, at a surface level, this seems totally possible. Theoretically, it should work perfectly to show curvature or lack thereof, without any of that refraction nonsense. And while I dislike the 8 inches per mile squared, over a relatively short distance of 2 miles, it's close enough that I'm not going to argue with it. You should see a difference of about 32 inches over this distance. But when we start looking at the practicality of the experiment, you start to see the issues. And once you look at their $100,000 GoFundMe, you start to see the scam. Why $100,000? And why haven't they done any of the actual planning before asking for money? They don't have the land, they don't have quotes, and who's actually going to be building this? Now, based on their GoFundMe and all of their follow-ups, they clearly want to build a full physical fence or wall. Now, what materials are you going to use? How are you going to manufacture them? And how are you going to connect them? You're looking at the angle of the last beam changing by only 0.0289 degrees compared to the first beam, and there's over 1,000 10-foot beams in between, based on the original video. You would have to have some alarmingly precise machining. Now, this level of precision is possible, but it's not cheap. It would need to be steel and not something more in your budget like wood. Then you have to consider connecting the beams together perfectly every single time. A bit of dirt or water between them and they're no longer perfectly flush. In a normal project, these extremely minute errors would not make a difference. But you're trying to do this over 1,000 times. Each small error adds up. If you're off by 0.0000289 degrees a single beam, you wouldn't notice. But if you're off by that much or more on each beam, your result is going to be incorrect. The amount of expertise and precision needed for this to work in the real world is not practical, and is certainly impossible for some math-challenged flat earthers. Basically, it's a garbage experiment that's destined to fail from the outset. And flat earthers have done an experiment like this in the past. A group of flat earthers actually went out and tried this forced line experiment using the latest and greatest of surveying equipment, which cost around 4,000 human dollars. And guess what they discovered? Curvature! But like concave curvature. So not a sphere and not flat, but actually curving the wrong way, like we're on the inside of a ball. It's a little alarming that people actually give money to groups and projects like this. Anyway, I've been baffled by reality. Don't throw your money away, people.